Morning, everybody. You have already seen the differences between the physical and chemical changes. At this stage, we are focusing on the chemical reactions. And there are two parts to this because the first part is to know how to write a word equation. And I think that is the most important aspect of this particular topic, right? And also we will just revise what are the chemical evidences, all right, of the, no, not chemical evidences, the evidences of chemical changes. All right, so let's just go back and just revise on this. There are four different types of evidences that you can see in a chemical reaction. Precipitation being formed, all right, and also you can see a bit of light and heat, and most of these GIF images here will show you that there is a color change, that there is heat being produced as well. Okay, so color change is, as we see, is one of the most obvious evidences. Heat and light produced, as we have mentioned, and the production of gases too. Now, this is something that you might want to think about, and this is about how and why leaves change color, right? So if you can see the color that gives the leaves, all right, the color that gives the leaves is contributed by the different pigments. So you can see that green here is contributed by the chlorophyll pigment, xanthophyll contributes yellow, carotene, as we hear about carrots, all right, is orange in color, and anthocyanin, which is red, and this gives you the red color of certain leaves. So anyway, you can read this on your own in the slides that I have already put up. So this is a very interesting concept of a chemical reaction. And this here will give you an overall background on why that different autumn leaves have different, colors. And as you can see from inside here, in terms of the compounds, I'm not expecting you to know it, but you definitely need to know that there are elements which you have understood in the process. Okay, so if you want to enlarge it, recognize some of the elements. When I say elements, these are the substances that can never be broken down, and it's all represented by the symbols. Okay, why are substances different from one another? As we all know, all substances are not made the same, right? So they are different because they have unique characteristics, and this unique characteristics is known as your properties. So if you look at these two diagrams over here, you'll notice that H2O, a water molecule, is very different from a hydrogen peroxide molecule, H2O2. If you look at the formula very carefully, there is an additional hydrogen. So having said that, if they have an additional element or an additional atom, it will be completely different, unless of course it's just the arrangement. All right, but for the time being here, every every substance is unique, and every substance will have that property. You will need to also understand the law of conservation of mass, because in any reactions, whatever that you have reacted before will be the same as the ones produced after. So if we look at this example here, you have copper reacting with sulfur dioxide to produce copper sulfur and oxygen. Notice in terms of the number of atoms, they are all the same before and after. Okay, the only difference is the arrangement that they have. So the law of conservation of mass says whatever atoms that you react before in the reactants is the same as the number of atoms in the products, right? The number and the mass do not change. It's only the arrangement that you got to really bear in mind, all right? Having said that, we have to define a chemical reaction. So a chemical reaction can be defined as a process to rearrange atoms to form new substances, because remember, one of our evidences here is that new substances are formed. So atoms will need to rearrange themselves from the existing reactants, which are the substances before, to produce the products which follow suit. Yeah. Okay, and for us to do so, we need to know how to write an equation. At your stage, you are being exposed to writing a word equation, but you can't be able to write a chemical without knowing the formula. You may know on simple ones, but not at this stage. Once you proceed to grade 9, you will understand how to form those substances. All right. So a word equation here is a simplified form of any scientist to tell us what is going on with the reaction. So there are three parts to this word equation that we need to know. The first part here would be the reactants, which are the old substances which are reacting in the initial stage, followed by an arrow to say that the reaction has moved from the left-hand side to the right-hand side. And as we can see over here, the products formed are new substances, okay? So this is something that you need to know. Please avoid using this type of box arrow, all right? Because this is only just to give you an example. The way for you to write it is just basically a single line with the two heads being formed, okay? So that is what you need to know. But as far as I'm concerned, you just focus on knowing which are the reactants and the products. So let me just give you an example so that you can consolidate your ideas over here. Okay, so your reactants, you have hydrogen gas reacting with chlorine gas to produce hydrochloric acid. Notice that your hydrogen here is made up of two atoms. Remember, we mentioned about atoms being the particle of an element. Yeah, so you got to look at this very, very carefully. Yeah, and we have chlorine too as well. So H2 and Cl2 gives you two of HCls. But you see, the number of elements remain the same. Number of atoms of an element remain the same, right? Two H's and you have two H's here. Two Cl's and you have two Cl's. So in other words, whatever happens, it is always conserving that mass or even the number of atoms or even the element itself. Okay, when we do more practice for the word equations, you will realize how to write it. And if I were to write it down, I would have written as hydrogen reacts with chlorine to produce hydrochloric acid. That's the basic statement that you will need to know. Okay, and the next one that I'm going to show you is a non-examinable slide, but this is only just to tell you how we can write a chemical equation. But at this stage, I'm not focusing on that. I am just showing it to you. And don't forget, you will also be given in the exams because you are not anticipated or expected to write down the reactants or the products because you have not learned to write it down properly. Unless, of course, it's simple ones like hydrogen, water, carbon dioxide, sulfur dioxide, or even ammonia. Okay? So this is just to give you an illustration how the atoms and elements can be conserved. Yeah, so this is what we call a chemical equation, writing the formula. In chemical reactions, there are some reactions that will release energy and some that will absorb the energy. That is what you need to know so far. The reaction that releases energy here is basically an exothermic, all right? You look at the word exo, not the K-pop band, but exothermic as in the chemistry. Exo means exiting. Thermic is heat. So heat is exiting from the reaction or energy being released. Then you have endothermic, whereby the products are being formed and you notice that heat is being absorbed from the surroundings. So remember, whatever that happens around here is whether heat is released into the surroundings or heat has been absorbed from the surroundings. That you got to double check. Okay? All right. If you have any questions, do pop me a message and we will take through this the next couple of weeks. Okay? All right. Thank you very much.